So in this question here, we're going to do the binomial expansion of 2x minus 3 to the power of 7. Now what we don't want to do is to write this all out 7 times. So if we did this and then try to multiply that all together, that's going to be a right pain. So what we have a formula which saves us a lot of time, and there'll be a lot of mistakes along the way because that is really complicated. So let's use the binomial expansion formula and take this off the board. So what we have is we have a general formula. So we have an a plus b to the power of n, and we write that as a summation. So we use the sigma notation and we set a variable from k equals 0 to this indice. And then we have n choose k. So that's a binomial coefficient, which I'll come to in a moment. So n choose k, so n would be that indice and k would be where we are in the summation. Then we take this term a and raise it to the power of n minus k. And then we take the second term in the brackets, b, and just simply raise that to the power of k. Now you could do it the other way round if you like, because this would be symmetrical. K equals 0 to the n choose k. Then you could do a to the k and b to the n minus k. That would also yield the same result. So that is also valid. So anyway, I'm going to use this one today. This one we don't need. Okay, so now what we need to do is decide on what our variables are. We've got our k, which is in the summation formula, which goes from 0 to n. So in this case, our n is 7. So if we're working on 2x minus 3 to the power of 7, our n equals 7. Our a is 2x. And the b, just be careful with that because there's a minus sign here. So b is minus 3. And I recommend that these two terms you write in brackets. I'm going to explain that in a moment, because this minus sign and this coefficient here, got to be careful when we're dealing with this formula. So 2x minus 3 to the 7. So now let's go through the sigma notation. So we've got k equals 0 to n. So k equals 0 to n, which is 7. We've got n choose k, so that's 7 choose k. A to the n minus k, well we've got 2x. And then raise that to the power of 7 minus k. And then b is minus 3, and raise that to the k. So that's our general setup for this question. Now this one here is our binomial coefficient. Now what we have here, we have n choose k. For example, in this case it's a 7 choose k. And then we can write that as is n choose k. Now that's what it would appear as on your calculator. So n choose k, so it's how many combinations of k inside n. Now the formula for that, we have n factorial divided by n minus k factorial times k factorial. So that's how that's worked out. So in this case, for example, if k equals 3, so for k equals 3, we have 7 factorial divided by n minus k. So 7 minus 3 is 4. 7 minus 3 factorial, and then the k itself, which is 3 factorial. So that's how we work that out. So if we want to work that out, 7 factorial is 5040. 7 minus 3 factorial, well that's just 4 factorial, so that's 24. And then times that by 3 factorial, which is 6. And then we can sort of calculate what that is. 5040 divided by 144. And that would give us our value for when k is 3. Now the other way we can do this is use Pascal's triangle. Now, this is the way I prefer, but this one is also pretty straightforward as well. So we just set up a triangle of numbers. So start off with 1, 1, 1. And then what you do is you add up all the gaps in the number above, in the row above. So we've got 1, 2, 1. 1, gap here is 3. So that's that one. And then you just keep going down until you get to your specified number n, which is 7. So we got 1, 4, 6, 4, 1. So for whatever your n is, that will be the appropriate one here. So here for n equals 7, we want this one. And then for n choose k, our k's are along here. So we've got 0. If I put k equals 0, 1, 2, 3, 4, 5, 6, 7. And that will give us our binomial coefficient there. Okay, let's just take some of this off the board and let's continue with this. Okay, right, let's just put this in a nice little box, keep that separate. Okay, right, let's go with it. Let's go with this. So from k equals 0 to 7, so let's write them all out. So this is our question. So I'm going to write an equal sign. I'm not going to write this out every time. So when k equals 0, I've got 7 choose 0. And then if k is 0, 7 minus 0 is 7. So I've got 2x to the 7. Now if I leave it like that, that just looks like 2 times x to the 7. Now remember I wanted to put it in brackets. So if I put a bracket around it, remember this indice also applies to this coefficient. So we've also got 2 to the power of 7. So 2 to the power of 7 is 128. So times too small if I just did 2x to the 7. So that's not the same thing. And the same here, minus 3 to the k. Put that in a bracket, because if I didn't, I just put k0 minus 3 to the 0. That could be construed as minus 1. So I just want minus 3 to the 0. So if I just rewrite that as minus 3 to the 0. And that takes care of that. So now when k is 1, add that, 7 choose 1, 2x. Now what you'll notice here is these indices, that one drops by 1, this one increases by 1. So I've now got 2x to the 6, minus 3 to the 1. Next one, 7 choose 2, 2x to the 5, minus 3 squared. So you notice that these values will alternate. So minus 3 to the 1 is minus 3. Here we've got a positive value because minus 3 squared is positive 9. Okay, so 0, 1 and 2. So now let's go with when k is 3. So here we add 7 choose 3, 2x to the 4 minus 3 cubed. And we just keep going. Okay, so that's it all written down. So now we need to try and simplify it. So I'm going to move these coefficients down to the bottom here, and then we can use those when filling in our 7 choose k. Okay, right. So 7 choose 0. 7 choose 0 is 1. So I've got 1 times 2x to the 7. 2 to the power of 7 is 128. So I've got 128 x to the 7. And then minus 3 to the 0 is 1. So times that by 1. Next one, 7 choose 1. That is 7. So 7 times 2 to the power of 6 is 64. And that's x to the 6. And minus 3 to the 1, that's times minus 3. Next one, 7 choose 2. 7 choose 2 is 21. 2x to the 5. 2 to the power of 5 is 32. So that's 32x to the 5. Minus 3 squared, that's positive 9. Okay, next one, 7 choose 3. That's 35. So plus 35. 2 to the power of 4 is 16. So that's times 16x to the 4. Minus 3 cubed is, well, 3 cubed is 27, but it's going to be minus. So that's times minus 27. 7 choose 4. 7 choose 4 is also 35. So now I've got to add 35 times 2 cubed is 8. So x cubed minus 3 to the 4. That's going to be positive 81. Next one, 7 choose 5 is 21. 21 times 2x squared. That's just simply 4x squared. so times 4x squared, minus 3 to the 5, while 81 times minus 3 is minus 243. And then we've got these last two here, which I can just maybe continue here. 7 choose 6 is 7 times 2x, so plus 7 times 2x, and then minus 3 to the power of 6. 243 times 3 is 729, and the two minuses make it positive. So times 729, and then finally 7 choose 7 is 1, times 2x to the 0 is also 1. So I've got 1 times 1, and then minus 3 to the 7. 729 times minus 3 is minus 2,187. Minus 2,187. Okay, now we can simplify even more. So let's bring all the coefficients together. So 128 times 1 times 1. So I'll just write it down here as well, because this is going to be our final answer. 128 times 1 times 1, 128, and then x to the 7. So that takes care of that. So that's what's called our coefficient of x to the power of 7. Then we want the coefficient for x to the power of 6. So now we've got 7 times 64. So 7 sixes are 42 times 7 plus 7 times 40 is 28. So that's 448. 448 times minus 3. Let's just work that out here. 448 times 3. That gives me 24. 3 4s are 12. 4 3s are 12. Carry 1. And that's going to give me 13. So that's plus 1,344. But it's going to be a minus sign because I've got a minus sign there. So that becomes minus 1344 x to the 6. So that's my coefficient for x to the 6. Now my coefficient for x to the 5. 21 times 32 times 9. Well, 21 times 32, 20 times 32 is 640, plus another 32 is 672. So we now need 672 times 9. Well, if I just do 2 9s are 18, 7 9s are 63, plus 1 64, and carry 6, 6 9s are 54, plus 6, that gives me 60. So that gives me 6,048. And as this one here is all positive, I need a positive sign, 6,048 x to the 5. So that's the coefficient for x to the 5. Next one for x to the 4. I've got 35 times 16 times minus 27. Well, 35 times, let's do 35 times 27. That looks the easier one to do. 27 times 30 is 810. Add 135 because that's half of 270. So that's 810, that's 945 times 16. So we've got times 10 is 9450. And then 6 times 945, 6 5s are 30, carry 3. 6 4s are 24, gives me 27. 6 9s are 54, gives me 56. Let's add this all up and put that in. We've got a minus sign here, so we need a minus sign there. Notice these are positive, negative, be all the way across. Add these up, 0 and 0 gives me 0. I've got x to the power of 4. 5 and 7 is 12, so that's a 2, carry 1. 6 and 4 is 10, carry 1, that's 11, carry 1. And 5 and 9 is 14, gives me 1, that's 15. So that's minus 15120 x to the 4. So that's my coefficient for x to the 4. Now what about x to the power of 3? Let's have a look at this one. Where is it? Here it is. So 35 times 8 times 81. Well, let's do 35 times 81 first. So 35 times 8 is 280. So that's 2,800 plus 35, 2,835. So we've got 2835 times by 8. 5 8s are 40, carry 4, 3 8s are 24, that's 28. 8 8 64 gives me 66. 2 8 16 gives me 22. So now we've got 22,680 for x cubed. So add 22,680 x cubed. So that's a positive, so that's the coefficient for x cubed. Now what about x squared? We got this one here. 21 times 4 times minus 243. Right, that's a bit of a challenge. Let's do 243 times 21. So 243 times 21. 243 times 2 is 486. And add a 0 on the end for 20, that's 4860. Then add 243 to that. Now note that this is a minus sign, so we want a minus. Add these together, we get 5,103. And then we multiply that still by, because we're still on the x squared, we've got to multiply that by 4. So multiply that by 4. Well, 5 4s are 20. 103 times 4 is 412. So 20,412 x squared. So that takes care of that one. Now, what about this one? So just the x. So I'm going to have to bring this down on the next line. So it's going to be a positive because there's no negatives in here. 729 times 7 times 2. So let's do 729 times 7 first. So let's take that off. 729 times 7. 7 9s are 63. 7 2s are 14. 7 7s are 49. So 5,103. And then we times that by 2. We get 10,206 plus 10,206 times x, and then finally minus 2187 times 1 times 1, easiest question of the day, minus 2,187. Okay, let's take these calculations off. Okay, so now that is the answer, and these are all our coefficients for the terms of x, or 1 there, x to the power 1. So this would be the answer to the full binomial expansion of 2x minus 3 to the power 7. Now in particular 128 times x to the power 7 is our first one. So I'll put that one in a little circle. Okay.